Okay. So this is the slide from where we have to start, and I am also recording because I told you already. Uh, the topic is implication or conditional statement, and we are still in the topic of logical connectives. Logical connectives. So this is basically our topic. In this, we have all this negation, conjunction, discussion, disjunction, implication, biconditionals. So we are here at implications now. So we can call this implication also with another name, that is conditional statement. Uh, like for example, in your programming languages, you have the if statement for to handle conditions. But here we have that conditional statement, and how it will work, you will see. I don't know how to handle with this screen because I cannot see you. So, so we will go on with that, huh? I don't know. I don't know. I don't know. This is a tough. I believe you can. Previously, we did something like that. Jazakallah khair. So now it's conditional statement, and how we can represent this conditional statement in discrete mathematics. We will use this symbol, arrow from left to right. We will use this symbol. And how we can use this symbol for two propositional variables? If P and Q are two propositional variables, we can put this arrow, which is called implication or condition, between them like that. P, and how we can read it? P implies Q. P implies Q. And what is the reading or meaning of this P implies Q? This is the meaning. This is the meaning. If P, comma, then Q. So this is the meaning of this representation, this notation. So if P, then Q. Now, this is the definition. If we want to build a truth table for this P implies Q, we must know the definition. And this point, second one, is now the definition for this P implies Q. And it is saying it to us that P implies Q is false when this first one is true and this second one is false, then this whole P implies Q will have a false value in the truth table. Like here, first one is true, second one is false, and you have the false value according to the definition. And for all others, it is true. And for all others, you can see it is true in the truth table. So now some extra information. In this P implies Q, this first one, P, is called hypothesis. The other name is antecedent, or the other name is premise. I don't know the exact Arabic word for hypothesis, but maybe mafruza. Maybe mafruza or mafruda, whatever you want to say. Oh, yes. Yeah, in Arabic. So hypothesis, okay? So you will uh, assume something, and then so you conclude something. So this first one, P, is something, hypothesis. It is your assumption. It is your assumption. So that's why it is called hypothesis. Normally, when student do their thesis in the master's or in the PhD, normally first they build a hypothesis that we want. This is the claim. This is the claim, and then you will prove that claim later on in your thesis. So that claim is a kind of hypothesis. So the other name for hypothesis is antecedent or premise. And then this Q, this second one, we can see if this, then Q. So this Q is the result. Then Q is what? The conclusion. The other name for this conclusion is consequence. The other name is consequence. A conclusion that you get in a sequence is called consequence. So here it is the truth table for this implication, and you know how this truth table is going on. If you want to build a truth table for P implies Q, what you have to do first? First, you have to count the number of, I told you in the previous lecture. So if I ask you to build a truth table for P implies Q, then one column would be this P implies Q, as you are seeing in the truth table. One column would be this. But what would be the input columns? These are called input columns. Then what would be the input columns for that? How you can identify from the mathematical expression? By counting the number of variables. How many different variables that you have in that formula, in that expression? We have only two variables, P and Q. If you have two different variables, then you have to introduce those P and Q as an input of that truth table. So that P and Q is now you are introducing, and these are the possibilities. In the previous lecture, I explained you how you can do that. You can, for example, here you have two variables, to 2 raised power 2, 4. So there would be 4 rows. There would be 4 possibilities of what? Of truth values, of true and false values. So now you have to make all possible combination, but your number of rows would be 4. So then what? Here you are assuming, okay, I can keep it true, second true, and then I can keep first one true and second one false. And then I can take first one false, second one true, and then the one false, false. So either you can do this computation in this way, or you have two variables, 0, 0. You have two variables, P and Q. So you have 2 bits. And now you have to give me the counting. If the counting is like that, 1, 2, 3, 4, and so on, what is the 2 bits for this 0? For this 0 here? 0, 0. 0, 0 will represent. And what is the bit string for this 1? 0, 1. And then 1, 0. And then 1, 1. So these are the 4 rows now you have made. Now convert this 0 into F and 1 into F, and then you will have these values. This is another way. This is another way. I told you in the previous lecture. Okay. I told you in the previous lecture. So now, but I repeated only because I am looking at your faces and your faces are silent. So it means that maybe some are understanding, some are not. So that's why I just repeated quickly. So now for P implies Q, what is the truth table? What is the definition? It would be false when the first one is true, second one is false. It would be false, and true for all others. And now in English sentences, if something you will find like that as mentioned here, then that would mean that here you can convert that English sentence into P implies Q. So if you have something in the sentence like that, if, and then some sentence here, and then you have the word then, and then again some sentence here, this is the formation for the P implies Q. All these readings that you have here is equal to P implies Q. If you want to convert them, all these different patterns that are existing in English language, these are equal to P implies Q. If you want to convert those English sentences into mathematical expression, and if you will find something if in it, and then some sentence, and then this word then, and then some other sentence, then you can convert those sentences into these P and Q, X and Y. And then finally, you can convert your whole story, which is written into the form of sentence, into this P implies Q. Into this P implies Q. So this is one formula. Another one is if P comma Q. This is also equivalent to P implies Q. This is also equivalent to this notation, this formula. Sometime it can be like that. P is sufficient for Q. Some sentence here, and then these words is sufficient for. These are fixed, okay? These are like fixed. I'm saying fixed for your understanding, okay? But sometimes in language we can have the same meaning and we can move the words here and there, which will give us the meaning like that. Then it would also be okay. But okay, for your understanding, for bachelor class, it is something like fixed. You can take it as it is. So P is sufficient for Q. That if you will find something like that, then you can also convert them into this formula. For example, here, there is a sentence, if, and then I am elected. This is the sentence. And then the word then, and then there is another word, I will lower the taxes. So these are the two sentences. And this if and if, this the and, this is that formatter. If, and then you have here two sentences. So if you have something like that, you can convert these portions into P, and then you can convert also this portion into Q. And then this is what? If P, then Q. This is that reading. And if you have that reading, then you can simply convert it into this mathematical formula. P implies Q. P implies Q. And I am saying that all these things which are written here are equivalent to P implies Q. These are the different patterns that you can find in English language. All are equal to this P implies Q if you want to convert them into a mathematical formula or expression. For your understanding, I am using the word mathematical formula. Otherwise, mathematical expression, these are some sophisticated words. If you will find something like that, QFP, for example, I will lower the taxes if I am elected. I am just changing this like that. And then that would also be equal to what? P implies Q. Similarly, if something like that, you will find something like that. I am elected only if I will lower the taxes. That is also equal to something like that. So these are the different readings. And then here, I will lower taxes unless I am not elected. This is the negation, okay? So the P is what? I am elected. And then negation P is what? I am not elected. So if you will find something like that, I will lower taxes unless I am not elected. So due to this unless, this negation is there. And then the whole meaning is the positive like that. Okay. I will do that if you give me. I will do that unless you does not give me. The meaning is it. Okay. The word is, I don't know, maybe I can use the translator, Google Translator, and can give you some equivalent in Arabic, but that is not my motive now. Maybe, what is the word for in Arabic for this unless? Hatta? Hmm? Maybe. Hmm? Illa? Illa. Okay. So these are the different readings we will see. And now we have an example. Example 7. Let P be the statement. Now, Maria learns discrete mathematics. So this is one sentence and it is what? It is P. And then, and Q be the statement. Maria will find a good job. This is the second sentence and it is what? Q. And now the question is, express the statement P implies Q as a statement in English. So P and Q into the form of sentences are given to you. And the question is asking, what would be the P implies Q in English sentence? In English sentence. You don't have to convert them into P implies Q. No, conversion is not asking in this question. The English conversion is asking, is being asked here in this question. For example, according to this question, P is what? Maria learns discrete mathematics, first sentence. And Q is what? This Maria will find a good job. So this is P implies Q. So P implies Q in English. This is being asked in this question. Express the statement P implies Q in English. So write them in a sentence form. Write the P implies Q in sentence form. And it is easy. If you know if P comma then Q, if you have this thing, the first easy thing in your mind, then you can put the statement of the P here and Q here, and then it would be into the form of P implies Q, because it is equal to what? It is equal to P implies Q. Because all these things are equal to P implies Q. So you need only one pattern from all that list, if that pattern in your mind. And then put the value of P and Q in that pattern, and you will have your P implies Q in English sentences. So now, okay, I know that if, comma, then, and here this is the something I can put for P, and here I can put something for Q. So P implies Q if, and then P is what? P is this, Maria learns discrete mathematics. So I am writing that Maria learns discrete mathematics here. If, so this is equivalent to if P, and then comma, and this word, and then after this, then I have the place for this Q. So what is Q? This is the Q, this sentence. So Maria, you can write Maria will find a good job, or she will find a good job. That's okay. So now this sentence, this whole story, this is equivalent to what? P implies Q. But this is the formula in mathematics, and this is in English as an English sentence. Now I can write in other ways, because there are many patterns available on that previous slide, on here, many patterns. But this is the answer is finished here, because if you know the one pattern, answer is finished. These are the other possibilities, other answers. Because some student can like this if then, some student can like this pattern, some student can like this pattern, other student can like this pattern. So then you have to write according to those patterns. So now, for example, if I want to write like by using this pattern, a sufficient condition for Q is P. A sufficient condition for Q is P. Let's first have a look on the easy example. A sufficient condition for Q is P. It is also from here. Sufficient condition for Q is P. Let's see what this is the pattern. A sufficient condition for Q is P. So now I'm writing a sufficient condition for Q. Q is what? Maria will find a good job. A sufficient condition for Maria to find a good job. I have stopped myself here. A sufficient condition for Maria to find a good job, that is Q. And what is the pattern? A sufficient condition for Q is P. And now I am writing that is. A sufficient condition for Maria to find a good job is, and then P. P is what? Maria learns discrete mathematics. But you are writing in English, so you have to do something. You can do modifications according to English grammar or like that. So a sufficient condition for Maria to find a good job is to learn discrete mathematics. If I will write good job is Maria learns discrete mathematics, it's okay, but grammar is totally, you have done something bad with the grammar. So a sufficient condition for Maria to find a good job is to learn discrete mathematics. There is no need to mention Maria, etc., because the same sentence is going. And this is what learn discrete mathematics. This is P. Similarly, a little bit more complicated for the same pattern is here. For Maria to get a good job, it is sufficient for her. I am covering this a sufficient condition for her to learn discrete mathematics. So after modification, you can modify this sentence here in this upper example by moving the pieces here and there. That is also has the same meaning. So for Maria to get a good job, it is sufficient for her to learn discrete mathematics. We have moved some phrases here and there, but the sentence is same. And now for this one, Q unless negation P. Q unless negation P. Q here first, unless, and then we will use the negative sentence of that P. So what is Q? Q is what? Yeah, just a minute. How can I clear? So this is my Q. Maria will find a good job. So I am writing Maria will find a good job. And then the word unless. And then I have to use P, but negation P. So now I have to make it negative of this sentence. So Maria here learns, so does not learn. Maria does not learn discrete mathematics. So unless she does not learn discrete mathematics. That is easy. So now it's up to you. For this question, any one option can be the answer. Any one option you can select, and that would be the answer. Yes.
So the last option.
Yes.
Does it feel like it doesn't make sense? I will find a good job unless she learns. Should be the opposite.
No.
Does not find a good job unless she learns.
No. The meaning of this sentence is same as you have this sentence. So it means that if Maria want a job, she must have to learn discrete mathematics. This is the meaning of this sentence. If Maria wants job, I am using simple words. I'm not making the sentence lengthy. If Maria wants job, what is the meaning of this sentence? Maria will find a job unless she does not learn mathematics. So what is the meaning of this sentence? The meaning is, if Maria wants job, she must learn discrete mathematics. This is the meaning. Okay.
What I want to understand from this question, how can you apply truth table to this question?
How can we apply
truth table? This question, truth table.
Truth table.
Yes.
How can we apply truth table?
This question is possible.
We are not talking about truth table here. Yeah, it is possible. If you want to find the truth table for the P implies Q, that would be the truth table there, which is displayed there. But if you want to discuss the values of true and false row wise with these sentences, if you want to discuss, yes, we can discuss. When it will come, you will see. There are some things which are related to this. It will come next. And there is some example in which there is a question that discuss the truth values of that problem. And then we will discuss. So we are just saving our time here, because here the question is different. You still have confusion in your mind or clear? It is due to language, okay? Whatever confusion that you have in your mind, because you are not accepting here that here Maria will find a job, you are taking this sentence like that Maria will find a good job without learning discrete mathematics. This is the meaning coming into your mind. This is or something else?
Yeah.
So because this is other language, so if maybe I will use Google Translator here, and then you will accept that it is okay.
Doctor,
Hmm?
I think in his mind he means, what if I learn programming, for example?
No.
So I have to have a good job with only discrete math.
No. That is not the meaning. This is just an English
No, I
sentence.
think that's what he thinks so.
I don't think so, because are you taking this like that as he is saying? What is happening? Let's see, it's okay or not, I don't know. Read it and understand it. Here the sentence is something positive or negative. Here the meaning is that Maria find a job. What is the meaning of this sentence? Maria find a job if she must learn discrete mathematics. It is the meaning. Now you are accepting this. Okay, Jazakallah khair. Okay, now the topic is changed. Now the topic is converse, contrapositive, and inverse. Converse, contrapositive, and inverse. What are these? These are the three definitions here. So you have to take P implies Q in your mind, because we have studied. We are still in the same topic, P implies Q, but there are some other concepts related to this P implies Q. So that's why we are covering these concepts here. What is the converse of P implies Q? What is the contrapositive of P implies Q? What is the inverse of this P implies Q? So what you have to assume? You have to assume P implies Q in your mind. You have to take this P implies Q in your mind, and then the question is, what is the converse? The converse is Q implies P. The converse of P implies Q is what? Q implies P. Now, this is something you have to memorize. Q first, P after, and the arrow in the same direction as it was. This is the converse. And what is the contrapositive of P implies Q? So this converse, but then you will introduce negation. It is the converse, but you will introduce negations. Okay? I'm just saying so that you can memorize it easily. What is the converse of P implies Q? Q implies P. Just shift the variables. And what is the contrapositive? Just introduce negative symbol in the opposite, in the converse, you can say. And then what is the inverse of P implies Q? Here you don't have to change the position of the variable, that is same. It is inverse. Inverse means exactly negative or opposite. So then you only have to introduce negative symbols. Negation. You only have to introduce negation. Converse is something, the reverse of something. Okay, the reverse of something. It is okay. The meaning is something converse, and inverse is something close to each other. But in converse, you have this option that, okay, if you have complete education and then 80% of the equation is reverse and some is as it is, then you can call it converse. But inverse, you cannot. It is completely negative, according to the definition in English, in mathematics. So these are the three different things that you have to memorize. And now have a look on this truth table and what is the effect of that. So if this is the converse, if this is the contrapositive, and if this is the inverse, and if I ask you to make a truth table for all for these one by one, then how many variables? Then the first thing what you have to see in the formula, count the variables. How many variables are there? So in all these expressions, there are two variables. So it means, yeah, that your input columns would be two, P and Q. So that's why here in this table you have these two input columns. And how? Only those four possibilities that you have here. The same possibilities that you have in the previous previous truth tables for 0, for 1, for 2, whatever it is. And then if, for example, now you can calculate the value of this Q implies P there in that next table, in that you can calculate this value. And what is implication? According to what is the definition? That when it will become false, when the first one is true, second one is false, it is false, and true otherwise. So now we are going to look at this Q implies P in the next table. Q implies P is here. So this is T, this is T, so I have T. Okay, let's see. When, sorry, you have to see what? This is Q implies P. You have to see in opposite direction.
Yes.
Keep it in mind. So Q would be true and P would be F. So here, Q would be true and P would be F. Then this would be false. Clear?
Yes.
Because here it is Q is here on the left side and P is on the right hand side.
In this case, is Q the hypothesis?
In
this case, Q becomes a hypothesis.
Yeah, it is a hypothesis. Yeah. It is a hypothesis. It is a hypothesis. And P is conclusion. I need your brains. Okay. Some people have left their head down. Don't surrender, huh? This is the starting. This is the starting. How you can deal with me in future if you are surrendering now. Do not surrender, please. This is just a beginning. This is not difficult. This is quite easy. The complex things are coming. After 2-3 chapters, the complex things are coming. And then you will abuse me. And then you will throw your shoes on me. And you will pull me out from that room, huh? So do not surrender. You are young, still young. And this is the time when you can learn as much as possible. When you will pass your 30s, then you will not keep any person even with you. You will throw them away. Anyhow, I told you that P implies Q. What is the definition of P implies Q? If you will look, P implies Q is false when this first one is true and this second one is false. Then it will become false. This is the definition. But here, we don't have P implies Q. We have Q implies P. So you have to apply the same definition then. The first one is true, second one is false. Then it will what? It will be false. So then here, this is the column for the Q implies P. And then the first one is Q. So I am looking at this Q. So when the first one is true and this P is false, then it will false and true for all others. You don't have to write true for all others. You have to look. Either maybe you will again have T and F somewhere in the row. If you are calculating something complex. So here TT, so that is not according to the definition. Q is F. I want first true, then false. And here we have F, and then okay, that will be true. This is not according to the F, okay, that would be true. So only this one is that pattern that is there in the definition. Anyhow, now here in the next, if you want to calculate the value for that, negation Q and negation P, what is the first thing that you have to do? You have to find negation Q and negation P first, and then you can find this implication. And then you must have to find the negation values for the negation Q and values for the negation P first. And then you can find this implication arrow. Okay. So that's why here we have this negation P and negation Q. And negation is what? The opposite of that. What is negation P? Opposite of P. What is negation Q? opposite of Q. So now negation P, this is the column for the P, this is the column for the P and its values. So if it is true, negation P would be false. If it is true, negation would be opposite, false. If it is F, opposite is true. It is F, opposite is true. How many students have understood this? Just raise your hands. You understood? Okay, good. And negation Q would be what? It would be the opposite of that Q, that Q, that Q. So write all the opposite. If it is true, opposite is F. If it is F, opposite is T. If it is T, opposite is what? F. If it is F, opposite is what? T. So now we have reached here. Now, if you want to calculate P implies Q, for example, P implies Q, because I want to calculate this converse, then this one, which is contrapositive, and then this inverse, that truth table is only showing all these things, the converse, the inverse, the contrapositive of what? Of P implies Q. So that's why here we are going to calculate P implies Q first, just to show, just to have a look on the values of that. So P implies Q. According to, now this is P hypothesis, Q is, so P is first, Q is second now. So here the first one is, if first one is true according to the definition, and second one is false, then what would be the value of P? This P implies Q? False. That is the definition. So now I have to look at this P and Q, this P and Q. First one is true. So here true. Second one is false. No, it is not false. So that's why it is true. First one is true. Second one is false. This is according to the definition. Then what? P implies Q is false. First one is false. Second one is true. This is not according to the definition. So that's why it is true. And then FF not according to the definition. That's why it is true. These are the values of these P implies Q. Or you can say this is the truth table now for the P implies Q. You can ignore them. You can ignore these columns, and then with these two columns and this one, this is the truth table for the P implies Q. Now Q implies P we already did. And now negation P implies negation Q. This is what? Negation P implies Q, negation Q. This is the inverse. We are going to find the value of the inverse. Negation P. So here negation P and negation Q. We have these columns negation P and negation Q. So for this, we don't have to look over this P and Q, because we have calculated this negation P and negation Q here. And the implication is between them. And the implication is between them. So same definition. When the first one is what? True, and the second one is false, then this column will have false value. This is the definition. So now look over these two columns here. When the first one is true and the second one is false, then this column will have false value. First one is true, second one, no, it is not according to the definition. True. First one is true, second one is false. No, it is not according to the definition, so it is true. This is according to the definition, so it is false. First one is true, second one is false. No, it is true. So that's why it is true. So here, these are the values. These are the values. Now, what is left? This one is left. Negation Q, negation P. So negation Q, negation P. Have a look over here. Here, negation Q on the left side, right side, negation Q. We have this negation. We have this. We have these columns already, and from these columns we can find. Now your negation Q, this is the first column and this is the second column according to this expression. And when the first one will be true and second one would be false, then this column will have false value. So now look over here, first one and second one. First true, second false. First true, Here first true is this one, second one is false, so that's why it is false. And then look over there, first one is true, here this one is true, second one is false, no, it is true, so that's why true. So all others are true except that one. And this P implies Q simply called implication or conditional statement. This Q implies P, opposite part. So converse, this is called converse. And this negation P, negation Q, we have already studied in the previous slide that this is inverse. And this is what? Contrapositive. So I can ask you that you have two proposition P and Q, draw a truth table for the converse, contrapositive, and inverse for them. I can ask you a question here. Now, based on this truth table, we have some results. We can say, for example, this green one, they have the same values, TFTT, TFTT. So it means that this P implies Q and this negation Q or negation P are logically equivalent. If I ask you to find the expression for the two uh, uh, statements or whatever are logically equivalent, this is the symbol, three lines for equivalence. And this symbol means not equivalent. In mathematics, these three symbols, three lines parallel, it means logically equivalent. That's equal, that you have this one, that is different. That is exactly equal, okay? That is logically equivalent.
There's a sentence, but then it's almost the same.
Yeah, sentence is almost. For example, this P implies Q and this negation Q, negation P. So they are equal. When their values are equal, then you can call those columns equal to each other. So what I'm giving you the definition. If you have to find that that the two things are logically equivalent, you can draw their truth table, you can find their values, and if the column values are same, then you can say that these two things are what? Logically equivalent. And how you can write in mathematics? Like that. P implies Q, logically equivalent to negation Q implies negation P. So these two columns are equivalent. Similarly, these two columns are equivalent. I have made their color same so that you can identify it easily. TTFT, TTFT, and the same input. Input is also same. The order, the tartib, everything is the same for these two both columns. So Q implies P is logically equivalent to this negation P. Q implies P here, written here. Q implies P, logically equivalent to negation P and negation Q. And so these are the equivalent things. And these P implies Q. This one, P implies Q. Not logically equivalent to Q implies P, which is the next column, this blue one. So they are not logically equivalent. Okay, yeah, it is clear. Their values are different. Similarly, P implies Q is not equal to this column, this blue one. P implies Q not equal to this one. So I am writing these equations only based on these truth values that we have here. That we have here. Now, example 9. What are the contrapositive, converse, and the inverse of the conditional statement? And that conditional statement is given here into the form of a sentence. A sentence is given to you into the form of P implies Q. And then the question is, what is the contrapositive, inverse, and the converse of this statement? If you look over this statement, the home team wins whenever it is raining. So there are two sentences connected with each other with this whenever. This is what? Whenever. Have a look over here. Q whenever P. This is that pattern. So when you have something like that, then the first sentence in that order is Q and the second is what? P. But this is equal to what? This is equal to P implies Q. Yes.
So are you simply trying to tell that we have to memorize this?
Yes, memorize this. Otherwise, you are not able to solve these questions. Yeah, you have to memorize this. You have to memorize this. Otherwise, it would be difficult for you. So you have to memorize this. This is just a small piece of cake. The things which are more lengthy and complex, and you have to memorize. Just wait, they are coming. And you have to fight with them, huh? But inshallah, I will try my best to give you the concept actually. Here I have only one restriction that I am sitting. And when you are sitting while teaching, that is not a good strategy because your body language, all that stuff also gives understanding to the students. But I am recording, so that's why I'm controlling. I already told you. But only but just 2, 3 lectures, and then I will deliver the lecture properly in a standing position, sometimes sitting, sometimes standing, combination. And then you will understand things in a better way. Okay. So this is Q whenever P. Q whenever P. This is the pattern here in this example. The home team wins, and whenever, and this second sentence. So the first sentence is now Q. This is whenever, and the second sentence is what? P. So that's why in these solutions I tried to convert all that stuff first into the form of P implies Q. That because P implies Q, which is if P then Q, that is the most easiest form. So here I'm just writing first because here in this question we have a Q whenever P pattern, which is equal to what? Which is equal to P implies Q finally. Then here according to this, the second sentence is P. This second sentence is what? P. So P is what? It is raining. And Q is then what? The other sentence, the home team wins is Q. So we have identified what is P and what is Q now. And P implies Q would be what? I am now converting it into P implies Q. That is not needed, but for easiness, you can do that and then everything will be clear to you. So P implies Q is what? If now I'm converting it into the if then format. And here if and here it is the P. So if it is raining, then the home team wins. Now I have converted that sentence in the most easiest form that I have. And now I can find the contrapositive, converse, inverse easily because I have the equations of converse, inverse, and contrapositive in my mind. And I have seen those equations in the previous slide. And those equations are these equations are written according to this P implies Q. This is the converse, this is the contrapositive, this is the inverse. And now if you know these things, if you have these formulas in your mind, what you only have to do? You only have to put the value of Q and P or P and Q in it, and then you have your answers in the English sentence form. So if I have this P implies Q in a sentence form like that, now what is the converse? Converse is just changing the position of the variables. Q implies P, which is written here. This is converse. And now what it means? It means if Q then P like that, it is like that. So if, and now here the Q is what? Q is the home team wins. So that's why if the home team wins, then it is raining. This sentence now that you have is the converse. And here in the question, what is the contrapositive, converse, and inverse of this sentence? You don't have to give me the answer in this mathematical formula, Q implies P, negation Q and that. No, you have to give me the answer in English. Okay. Okay, by keeping those formulas in your mind. And then contrapositive. Contrapositive is introducing negative signs with the converse. So here this is the converse, and introducing negative sign, negation Q, negation P. If this formula is in your mind, then answer is easy. And implication is what? If then. I am writing all that stuff in this if then format. So if negation Q, this is the Q, and you have to find the negation of that. The home team wins, home team does not win. That would be the negation. So that's why the home team does not win. This is negation Q. And then if it is raining, it is not raining according to that formula. It is not raining, negation. Clear? And similarly, inverse, you can read it by yourself. Okay, it is easy. Now the biconditionals. Biconditional means double arrow. Previously, you have only one arrow from left to right, but here you how we can represent biconditionals? Biconditionals, by implication. The other name is by implication or biconditional. By means two, like binary, which means two dimension. So biconditional statement, we have this symbol, double arrow for that, and P implies Q. And how we can write it? Like that, P by implication Q. And how we can read that? P by conditional Q, P by implication Q. Or you can say P double arrow Q. Okay. So you can do whatever you want to do because it is not our language. Okay. We can do all that stuff with that. So P by implication Q is the, so how we can read it? How we can read it? P if and only if Q. What is the meaning of this? The meaning of this is if and only if. So two ifs are there. If and only if. This is equal to if and only if Q. So what is the definition then? So that P by implication Q would be true. And if P and Q, these two columns will have the same truth values, either both true or both false, then it will be true. If this P and Q have same truth values, then it is true and false otherwise. For example, here, both values are same, so that's why it is true. Both values are same, so that's why it is true. And false otherwise. Here different, false. Here different, false. This is the truth table. Now moving on. Biconditional is also logically equivalent to this one. First, P implies Q and Q implies P. If you will first calculate P implies Q, if you draw the truth table for P implies Q, and then if you will calculate the values for Q implies P, and then you will perform if you will perform this and between these values in the truth table, then the finally values that you will have for this would be same. That's why it is logically equal. I can ask you to draw the truth table for this expression, but we will do that. That truth table is coming next soon. But this by implication is equal to going from left to right and then from right to left. It is the meaning. Actually, meaning is in the equation, you are going from left to right, whatever the value that you will have. And when you will come back from right to left, both the values would be same. So after making a conjunction between them, you will get the same value as we have for the by implication Q. And what are the other formats that you can identify this by implication Q in English sentence? This would be like that. P is necessary and sufficient for Q. So these two words would be there, necessary and sufficient. Two conditions. One is necessary, other is sufficient. If these would be something like that in a sentence, then you can have this thing in your mind that here you have to use by implication or something like that. If P and Q, and then conversely. In English sentence, you have if, then some sentence, then others. In place of this Q, you have another sentence, and then finally you will say and conversely. It is true and conversely, and in opposite direction, and in reverse direction. So this conversely is a reserved word, okay? Then this thing would be equal to this by implication.
Example, of course.
Yeah, the example is coming. Don't worry, example is coming here. There is no anything in this slide without example. Okay. So I will not teach you theoretical things. Okay. So you will see examples, okay? Even with the first semester, when I taught this discrete mathematics in the first class, I give them examples from the exercise of this book. And then finally they said, no, we don't have that capacity. Leave these exercises. We are not going to solve this exercise. So then what? I reduced the contents. And now I reduce the contents. So I have taught this course already 4 or 5 times here. And now this is finally I have left it because the other content I have thrown on the will of the students. Students don't want to study too much. Okay. And now you are asking, hey, do we have an example? And then at the end you will say, I don't want an example. Okay. You will say like that, huh? I'm just making fun with you, okay? Jazakallah khair. So if and only if. P if and only if. So this would also be something if you will find something like that, or if and only if like that, this one, if and only if, this also means by implication. Now let's see this example. Let P be the statement, you can take the flight. This is P. And let Q be the statement, you buy a ticket. This is Q. Then express P by implication Q in English. In English. Express this in English. So that is easy. You can take a flight, and then you can take a flight if it is P, and you can buy a ticket if it is Q. You can introduce if and only if between them, and it is P implies Q. Or you can introduce this if between them, and it is okay. This, yeah? Yeah, in the exam, you will see. So express this P by implication Q in English. In English. I am just up to this point. I'm not talking about this one. And then here discuss its true and false values. This would be the answer of yours previous question. So here P implies Q. So P is what? You can take the flight. And Q is what? You buy a ticket. You buy a ticket. And introduce what? If and only if between them, and it is equivalent to what? P by implication Q. Or you can introduce only if I double F. I cannot write here because I'm using mouse. According to this, huh? According to this. Or you can write, you can take the flight, but for that it is necessary and sufficient. Oh, yes. You can take the flight, which is necessary and sufficient for you buy a ticket. If we want to make a, if we want to use this one, P is necessary and sufficient for Q. The first one is what? Take the flight. Second, a ticket. Second, a ticket. For taking flight, P is necessary and sufficient for Q. It is necessary and sufficient to buy a ticket. Then you have to modify the sentence. Then you have to modify the sentence. You can take the flight, or but it is necessary and sufficient to buy the ticket first. You can modify the sentence if you want to use this thing. But you can keep these easy things for you to understand, if and only if. Now, discuss the now the second part, discuss its true and false values. For discussion of the true and false values, you must have to know the truth table of, or the definition of this P by implication Q. What is the definition? If the values are same, it is true, and false otherwise. If the values is same, it is true and false otherwise. Now here we are discussing P implies Q. The value for this P implies Q. For example, here, look over here. The value of this P implies Q. When it is true, when you have same. When it is true, when you have same. When you have P false, Q false, or P true, or Q false. Now we are discussing these values, okay, here. With respect to these sentences. So P implies Q is true when P and Q are either both true or both false. This is the sentence we are writing according to the truth table. That this, here the question is discuss its true and false values. And here you are just giving the definition. First, P implies Q would be true if both are true or both are false. Now you are discussing this both true and both false values with respect to these sentences. With respect to these sentences. The first sentence, which is P, is you can take the flight, you buy a ticket. So now, if both are true, if I buy a ticket, I can take the flight. If both are true. Now here in this sentence, I am assuming that if I buy a ticket is true. I have bought a ticket. Then I can take the flight. So both are true. So that's we are writing into the form of a sentence. We are writing this status into the form of a sentence. I have bought a ticket. I can take the flight. And then what is other? False. I do not buy a ticket. I could not take a flight. No. This is true, but how you can write it in a sentence with respect to the truth table? This is true. Both of these cases are true. Okay, both of this is the case for true. This is right. You are saying right. I am saying P implies Q would be true when both values are true. Here, you have to discuss these values actually. When P is true, what it means? I bought the ticket. And Q is also true. What it means? I can take the flight. This is what I want to say in sentence wise. And here false. What it means? I don't have the ticket, you can say. And what this Q is false. I cannot take the flight. This is simple meaning. This is what you have to say in English. And this is that one we already discussed. And now you have to discuss this one. The second case, when P implies Q is false, when you have different values. So what it means, if I do not buy a ticket, this is true. It means I bought the ticket, but I could not take the flight. I bought the ticket, but I could not take the flight. What it means? Sometimes it can happen in the real world. Sometimes in the real it can happen or not. Yeah, happens. You bought the ticket, but maybe the airline throw you out. It can happen. So this is also, so this is what you are discussing. This is what you are discussing. It's truth values. And then here, you don't have a ticket, but you can take the flight. It can happen or not. If you received the ticket through some lottery or whatever, you didn't buy that. You just received that, and that you can take that. It can happen or not. So this is what it means. This is what it means, and here it is discussed. When so P implies Q would be false when both Q, P and Q have opposite values. And when these, what is these situation? That is when you do not buy a ticket, but you can take the flight. For example, you have the free trip, and you have this ticket through some lottery or some other person has arranged it for you, or you buy a ticket but you can take a flight, airline bumps you out, huh? So this is what this second portion here, this is the discussion of true and false values, nothing else, into the form of sentences. And this is the answer for the first part of this one, express P double implication Q in English. Okay, I still have a time, 8 minutes, or time is finished. According to the timetable, it is finished, huh? 9:20, huh? Okay. Yeah, I will start from here next, inshallah.